We start off by taking our differential, and our differential again is dy is equal to f prime of x times dx. Now, do keep in mind here to find my derivative, I am not going to sit there and do the quotient rule because I have a number over a variable. I'm going to bring all that variable expression up and rewrite the expression as y is equal to x plus 1 to the negative 1. So with that in mind, my dy is going to become, using the general power rule here, negative 1 times x plus 1, subtract 1, we get negative 2. The derivative of the inside is just 1, and then we multiply that by dx. Now, it's usually a good idea to get those negative exponents down to the denominator. So that gives us our dy. Now, on the previous questions, we kind of just stopped there. Now they have numbers, though, that they are giving us. So I want you to think about x is equal to 1 as the exact input. And then this dx represents a change in x. So this is kind of like a little perturbation that happens to the input. So perturbation to the input from x is equal to 1 to 0.25. So if we do that, then this dy is going to tell us the approximate change in our output. So what will happen, I plug in my x is equal to 1, so I get 2 squares, that gives us 4. And then the dx is 0.25, so we're looking at negative 1/4 times negative 1/4, we get negative 1 over 16 for our dy. And again, when you think about what dy represents, is that is going to be an approximation for the exact change in y if we perturb the input x by 0.25. So basically, if we increase the x value to 1.25, the approximate change in our output is going to be negative 1 over 16. So it's kind of telling us like how sensitive we are to changes in our inputs.